Okay, each day this week, it's exponential. Exponential is like, you got to focus on the y's. 2 times 3 is 6. 6 times 3 is not 8. So, again, linear, AROC, constant. So positive and negative of the same one. Okay, we got to check the AROC. Put on the wrong line. AROC. Down, up 4. Up 6. So 2/3. 2, up 3. 2/3. Down 4. Up 6. See, there's negative 2/3. So linear is out. So this is absolute value. So that right there is the vertex. Let's see. It's rising up this way. It hits that, and then it starts going down. So, equation, we're going to use 0.28. Okay, and A is determined from this point to the right. So A is negative 2/3 because it opens down. So it goes f of x equals negative 2/3 x minus 2 plus 8. So here we got negative 2/3 times. A lot of people miss this on the quiz. That's a negative. Negative 10 minus 2 plus 8. So this way. All right. The absolute value of negative 12 is 12, and you got to multiply them. So that gives you negative 24 over 3 plus 8. So therefore, f of negative 10 is 0. That's the that's an x-intercept. Okay, I know this one's not linear or exponential because we went down 12. Not linear. AROC would be negative 12 over 1 doesn't equal. So it's not linear, not absolute value, because it's not positive and negative at the same kind of slope. Okay, we don't know A. Okay, we're going to teach this through the week. Okay, we're going to learn so B y2 divided by y1. Okay, so with this equation, we can write it a little bit different. Is we know we have to find x, which is 0. We can find the y. So the equation has what is called a horizontal shift. Okay, so we're going to go g of x equals 16. And I know that's not the initial amount, but we're going to do 16 times 1/4 to the x minus 2, because we're trying to figure out what 0 is. Okay, or for me, or you could write a different equation, is you could multiply. So if I go back 1, you could multiply by 4, and then I could multiply by another 4, and I could get that 256. So you could do 256 times 1/4 to the x. Okay, but we're trying to find, it's got a phase shift. So we look here, it doesn't matter which one you plug in for it, okay, is if we got to find x of 0, okay, alright, so if I go with, I like to go with this one, so 256 times 1/4 to the 0. So see, if you go here, if you try to find the x that are 2 more before it, you get 16 times 1/4 to the 0 minus 2, which is negative 2. And then this would be like g of x equals 16 times flip it and square it. And see, you still get that 16 times 16, which is 256. Okay, so a farmer buys a tractor for $75,000. So the initial amount would be $75,000. Okay, it says the tractor depreciates in value by 14% each year. So on your reference sheet, so reference sheet says y equals a parentheses 1 minus r, because 100% of the sample has to be taken into account because you're doing minus 14% of that 100%, which was 75,000. And it's always to the t power. So, and r has to be a decimal. So 14% to a decimal. You're going from percent to decimal. You go to the left 2 places. So that's 0.14. So we put it together. And it's wanting f of x. I put y. Please forgive me. We'll put f of x. No, v. Okay, v is we do. That's 0.14. So v 75,000. We got to keep 100% of it intact, and then we're taking 14% off. So using the formula from if the growth factor R is the growth rate, the growth factor is 1 minus 0.14 to the. So instead of t, they want us to use y for years. So here we have v 75,000 and 0.86. I always make you simplify it to that. Okay, now you are going to have to use the calculator for this. And then y is 8. So we go, if you like a fraction, if you like, okay, I forgot to press record. So I think we were at this point right here. I was writing in gold. Let's see. We had v equals 75,000 times 0.86 to the 8. Now I was going to show you how to do it in your calculator. Let me pause the video. Okay, so you could go to y equals and put it in, just so you could look at the depreciation of the tractor. And we're going to raise it to the x power. And we can hit second graph. And there it is right there. It rounded. Or you could go second quit. You could go 75 G's. Oops. 750,000. Parentheses. That decay factor. Up the decay rate to factor. So it wouldn't be worth that much. Okay, now we're getting into the exponents. And again, the only way to get better at exponents is practice exponents. Okay, I already taped this once and thought it was recording and it wasn't. Classic me. Alright, so I can put the answer key over there. I don't need it. Alright, way 1. Okay, I call this way 1. Follow the rule. -5 plus 3. Because 2 powers of the same base, you add their exponents. And then that goes in the bottom of a denominator of a fraction. And it turns it into a positive power. Way 2, we do 1 over p to the 5th times p to the 3rd over 1. And see, you could go p to the 3rd, take 3 p's up here. Now a lot of people are like, what's that do to the top? Well, it gives me p to the 0 over p squared, and then that's 1 over p squared. So that's another way you could do that one. Okay, whenever you see anything to the 0 power, that whole thing is 1. Okay, power to a power rule. I'm going to use parentheses this year and see if it helps. Is when you see a power to a power, it's kind of got a parentheses already out there, so there's already a parentheses separating. So I get x to the negative 10. Okay, we only need to move positive or negative exponents to the denominator. So up here, we have basically 1 over x squared, x to the 10th, x to the 10th, times y to the 10th over 1, so y to the 10th over x to the 10th. That red pen's dead. I mean, I have seen some people do this. 1 over I've seen some people do that. It's where they flip it upside down and then they square it. But me personally, I'm going to follow the power to a power rule, which is 3 to the 1 times negative 2. Because every non-zero number has an exponent of 1. Now we're doing 3 times negative 2. So now I've got 3 to the negative 2, which is 1 over 3 squared, times x to the negative 6, which is 1 over x to the 6. And then that turns into a positive 8. So final answer, 3 squared is 9. If you did it this way, you can see you get 1 to the 1 squared, which would be 1. And then down here you'd have 3 to the 1 times 2, x to the 3 times 2, y to the negative 4 times 2. You can see that leaves us y up top. And then here we get 1 over 3 squared, which is 9. And then you move y to the negative 8 up, but you still get the same answer. Okay, anything to the 0 power is 1. That's 4 to the 1st. Okay, so we're doing 4 to the 1st times 6 to the 1st. And then we got x to the negative 4 times x to the 1st times y to the negative 3. So you can see that's 24. X to the negative 4 plus 1. Y to the negative 3. So now I got 24 over 1 times x to the negative 3 over 1 times 1 y to the negative 3 over 1. Okay, so I'm going to go up here and finish it out. I got 24 over 1 times 1 over x to the 3rd to make that a positive power times 1 over a y to the third, which makes that y to the positive power. So now we got 24 over x to the third, y to the third. Simplify inside first. So that leaves me with this. I got negative 5 m to the negative 3 minus 2. And then n to the 4 minus 5 squared. That's the way I handle it. And this is really negative 5 to the first. It's inside parentheses. So now I've got negative 5 to the first, m to the negative fifth, n to the negative 1 squared. So now I got negative 5, 1 to the second. And again, I'm using parentheses, so because there's parentheses right there to let you know, hey, I got to multiply those exponents. So it gives me 25 m to the negative 10th, n to the negative 2. So now I got 25 over 1 times n to the negative 10th over 1. Because all that operation happened up in the numerator. I teach this way different probably than most people. 1 over n to the 10th. The second we put it in the denominator, it makes it a positive power. 1 over m to the 10th would be a really small number. Okay, if you wanted a alternate strategy, alright, if you wanted to do it a different way, you could do it this way. Let's go back to the original. Okay, you could have done it this way. It's a negative 5 to the first. You could have done it this way. You could have done negative 5 squared, power to a power. M squared squared is n to the fourth. N to the fifth times n to the squared is n to the 10th. So we could have done it that way and got 25 over 1 times m to the negative 6 minus 4. And then we could have had n to the 8 minus 10 over 1. And now we got 25 over 1 times m to the negative 10th over 1 times n to the negative 2 over 1. Rewrite them, positive powers, times. And see, I still get that 25 over n to the 10th n squared. I mean, so you could do it that way. You could do it this way. I'm just giving you a lot of options. Okay, let's go back to the original. Okay, so here in orange, we could have done, okay, that's a very complex base, so we could have multiplied that by itself once or twice, even though it's that crazy one. So I'm giving you a different strategy here. To see, I could do -5 times -5. And I can go m to the -6 n to the 8 over m squared n to the 5th. Did I write that wrong? I think I'm going too far. It'd be m to the 4th. Sorry, n to the 10th. Then you get 25. N to the 8th stays up top. Okay, on the bottom I got m to the 4th times n to the 6th times n to the 10th. So there you can see now I got 25 n to the 8th and then you can take all 8 n's from the top, factor them out, you get n to the 0, which is 1. Then you got m to the 10th n squared. So